All right. Hello, eighth graders. Hope your quarantine time is going well for you. This is Mrs. Droja, if you remember me from last year. If not, hello. And I'm going to be helping out the eighth grade for Mrs. Bruno because she's going to be having a baby any day now. So please feel free to reach out if you have any questions or need to check in about anything. All right, so what I'm going to take you guys through today is equations that have variables on both sides of the equal sign. So this looks like the equation below. All right. What you guys have been working with up until now is solving systems with substitution. So you might see something that looks like the equation below. Notice in this equation, if we find the equal sign, our terms that have the variable x in them are on the same side of the equal sign. So here, since the 5x and the 2x are on the left side of the equal sign, when you go through to solve this equation, you just combine those terms, rewrite it as 7x minus 10 equals 18, and then you go through and solve that out by balancing, okay? The difference of what you're going to see today is if you look at this original equation below, I see 3x and 15x, which are like terms, but the difference here is that they're on different sides of the equal sign. So we're not going to be able to just combine them and get 3x plus 15x is 18x. Okay, so I'm going to take you through exactly how to handle this type of situation. So let's start with a visual up here. If I gave you this visual like a puzzle and I asked you to solve for x, think about it. And what you would likely do is balance it by taking two of these x boxes out of the situation. And with that one move, you're left with x being equal to 12. Let's take a look at how this would be algebraically, okay? So on the left side, I have 3x, right, which comes from these three x boxes up here. So there's three of them, so we have 3x. On the right side here, we have 2x, and then there's 12 of these one boxes, so we're just going to call that 12. It's a constant, okay? So think back. What we did visually, we removed two of these x's from both sides, right? So we're going to do the same exact move down here. How it looks algebraically is we subtract the entire term of 2x from the right side. And we know how equations work at this point. If you do it to the right side of the equal sign, you got to do it to the left, right? When we do this, what we end up with algebraically is exactly what we want. We want to have one side with the variable and the other side with a number. All right, so it keeps blocking my answer, but we ultimately end up with x equals 12. Let's take a look at one that's a little trickier. All right, so here we've got another visual. Notice we've got some x's on both sides of the equal sign. So if we want to represent this and go through and solve it algebraically, on the left side, we have 2x coming from these boxes here, plus 10. If you count these out, there's 10 of those. On the right side, we've got 6x, 6 of these guys, plus 2. All right, so starting with the visual, if I want to group it so my x's disappear from one side, I generally like to take the smaller amount and get rid of that. So I cross out these two up here, and I have to make sure I do it to both sides to keep that balance, right? So how we do that algebraically, again, we just subtract this entire term to get rid of it. But I can't just do it to the left. I've got to do it to both sides to keep that balance. When I do that, 2x minus 2x, that goes to 0. So those guys cancel. And I just rewrite my equation. Notice I'm just bringing that 10 down. 6x minus 2x gives us 4x. And nothing has happened from the two. Now, hopefully you're looking at this equation and you're like, all right, that's something I'm familiar with. From this point, we're going to remove 2 from each side. And you can see that up here visually as well. Algebraically, we're just subtracting 2 from each side. It's going to cancel from the right. And now we're left with 8 equals 4x. Hopefully that's something we can kind of just do in our head, but let's show our work. Divide both sides by 4, and we end up with x being equal to 2. Okay, we always want to check our work. So when x equals 2, we can plug into our equation. Always go back to the original equation. 2 times 2 is 4, plus 10 gives us 14. 6 times 2 is 12, plus 2 gives us 14. We know 14 equals 14, right? And we could also plug it into our boxes up here. And when that works out correctly, we know we've done the right moves. All right, let's try to get away from the visual here. Notice here is our good old equal sign, all right? And if we want to balance this, we cannot just add 5x and 2x, all right? So I like to move the smaller coefficient over to try to keep it positive. So I'm going to choose to have my variables on the left side and get all my numbers to the right side. Again, it's kind of like a puzzle. So in order to do that, since this is a positive 2x, it doesn't matter that this is subtraction, this whole term is positive, we are going to subtract 2x on the right side and on the left side to keep that balance. We'll notice those are going to cancel out, which is why we chose to do that. And we rewrite our equation as 3x plus 7 equals negative 5. Be careful that this 5 needs to be negative. Remember, subtraction and a negative are the same thing. So we bring down this entire term, including the negative sign. From here, we've got our two-step equation. Just be careful with your calculations. Subtracting 7 cancels out on the left. Negative 5 plus negative 7 is the same, right, as subtraction, adding the opposite. And we're left with 3x equals negative 12. Divide by 3 on both sides, and we get x equals negative 4. Remember, take a minute to check your work. X equals negative 4. If we plug that in up here, 5 times negative 4 is negative 20, plus 7 gives us negative 13. Over here, if we plug in negative 4, we get negative 8 when we multiply. Minus 5 also comes out to negative 13. So we know we've done the right work. Here is another example. I just want to show you, just be careful with your positive and negative signs, okay? So once again, if we look at the equal sign, our variables are on opposite sides, and we want to get them together, okay? You can move the negative 9x term to the right or the negative 3x term to the left. It's totally up to you. Doesn't matter which way you move. I've chosen to take my negative 9x, and I'm going to move it over to the right side. How I move it when it's a negative term is simply just by adding, right? These two are going to cancel each other out. And when we move that, we just make sure we do it to both sides of the equal sign and line it up under its term. Those are going to cancel. Notice what's left on the left side is negative 10 because of that subtraction sign that comes down. When I combine these, negative 3 plus 9, I get a positive 6x. And the 2 is still there, so we just rewrite it as is. Now I've got a nice two-step equation, just like you've been working with. Go through, we're going to solve this. Make sure negative 10 minus 2, we don't do any silly calculation errors there. We're going to divide by 6, and ultimately we get our answer. At this point down, it should look very familiar to you. So the only new skill that you're learning here is how to move the entire term over. And it makes sense because it goes with everything you've learned about inverse operations. We can't just combine negative 10 and 2, right? We have to subtract 2 to both sides. It's the same thing, except we're moving the entire term over. Things to be careful about would be a problem like this. Before you jump ahead and try to move our x's, we need to make sure we distribute first. So there might be just busier equations where you have to combine like terms on the left or right side first, or distribute on the left or right side first. So just be careful with that, all right? So if this would be an example where I need to distribute on both sides. And now that I've distributed, I can move my terms, right? So as the 3 went into the x, into the 4, we get 3x plus 12 on the left. On the right, 2x minus 2. And now we would go through, move an entire term over, and get our answer. All right, so let's summarize what the skill that you learned today was. All right. We were working with equations like this, where we have our equal sign here and we have a variable on both sides. So what we need to do is choose one side to be a variable side and one side to be our number or our constant side. Here, I'm going to move my negative 3n to the left side by adding 3n to both sides of the equal sign. We rewrite our equation, and then we just go through and solve like you guys know how to do. All right. Again, make sure you check your work. N equals 1 is what we got here. So I plug in 1 for n in the original equation. And if it balances out like it does here, we know we are good. All right. Feel free. You can pause and rewind this video if I've gone a little bit fast. I look forward to working with you guys for the rest of the year. Reach out with any questions. Bye.